Hey, I'm Matt Schwartz and I'm the Welding Geek. On this episode, I'm going to show you one of the most essential skills it takes to build something as cool as this, TIG welding. We're going to do some 4130 steel welding and some aluminum welding. So let's start the video. All right, first things first, we need to talk about a TIG welder. This is again a Dynasty 300. It does both AC, DC welding. Some welders will only do DC. So you need a welder first. You need argon, which is the inert gas that we're using to shield. It's a shielding gas to shield the weld puddle to keep it from oxidizing like that, which it will. You can't weld without it. Some of the settings. You use DC welding, DC current for steel, stainless steel, titanium. You're going to use AC current for welding aluminum or magnesium. So we're going to start off on 4130 chrome steel welding. So I want to set it to DC current. We're going to run about 114, 115 amps. And I may change this when I get into the welding. There's something called a pre-flow, which is when you kick the pedal, it's going to start flowing the argon to purge the area of all the oxygen. And I have that set to 3/10 here. And then there's a post flow. Oh, wrong button. Post flow, which is set to 20 seconds. That's way too long for doing steel. This is set up for doing titanium. So I'm going to turn that down to about 10, about half that. And that just makes it so when you finish a weld, you hold your tungsten there, your torch, to keep the oxygen away from that weld while it's cooling. It's not there to cool the weld, it's there to keep the oxygen off of the weld while it's cooling down. So those are your settings, your amperage, your DC current, your pre and your post flow. Also, when it comes to your argon here, you want to make sure you're running, I run in between 20 and 30 CFM. You can be more, can be less, just depending on what you're doing. But to say an average is between 20 and 30. And that's argon CFM. So now that I have my welder set up, let's go over and start doing some tack welding and then some welding. And when I come to do aluminum welding, I'll show you how I set my welder up for aluminum welding. So let's get started doing that. All right, the parts of a TIG torch real quick before we get welding. We have our handle. You have what's called a gas lens. Now there are a bazillion different types of TIG torches and parts. This is what I run. It's gas lens. I run a 16th tungsten. You have your gas cup. This is a number 7, I think. 7, so it's 7/16 cup. A 16th collet, which the tungsten slides into here. Just a quick tip before you get welding, make sure your gas lens is tightened all the way in there, because if it's hanging out a little bit like this, you won't be able to tighten down your tungsten and it'll just be sliding in there. So this is the first part that goes in your torch. Tighten it down all the way, just finger tight, doesn't need to be tightened way down. Put your gas cup on. And I typically like to slide my tungsten inside my collet. Slide that in. And then your tail cap. Slides over all that. Tighten that down. And then depending on where you're welding, how you're welding, I usually back my tungsten up so it's about 1/4 of an inch hanging out. Maybe a little less, maybe a little more, just depending on how I'm welding. So that's how I set up my TIG torch. Tungsten, gas lens, gas cup, collet, tail cap, and the handle. So let's move on to the next step. Okay. All right, just a quick note. Welding rod. Can you see that in there, Jake? Yeah. ER80S-2. 80 stands for the tensile strength, 80,000 tensile strength. Some people use AR70 or doing chrome moly. We're going to use 80. When you start off a tube joint like this, you want to tack it in 4 spots on the quadrant. So I'm going to do that now, just real quick. You don't have to put the lens on there. And what this does for you, anytime you're welding, the heat and the weld is going to draw the metal. It shrinks. So it always wants to pull. So if you tack it on the quadrants, it's going to keep it relatively close to where it was at. Also, before you strike an arc, when you're first starting out welding, kick the pedal. You hear that hissing? That's the gas. I'm gonna kick the pedal. Okay, you can hear that gas rolling through there. Make sure the gas is going. Otherwise, it's gonna make a huge mess out of your weld joint. You may have to start all over. All right, we're gonna do our first little beads. Hopefully you can see what's going on here. I'm gonna start on the non-cup tube. I want my heat to concentrate on the non-cup tube. And then I'm gonna throw my filler metal in there, start my first thing, back off a little bit, and then add my next one. And you're just overlapping the puddles far enough back to make sure you're overlapping the center of the bead, because you can get a pinhole there. This is what I mean about letting the puddles cool in the oxygen-free zone. Now, can you see this little pin thing right here? This in there, Jake? Can you see that?
The little hole in the middle of the puddle?
Yeah.
Yeah.
That can potentially be a pinhole all the way through the weld. Okay? And so it can also be this little glass bead. What I like to do, and I learned this from the guys here, is you can actually, I think there's one there, take a scale and pop that little glass bead just like that. It's probably really hard to see because it was really small. But you can pop that little glass bead out of there. So next time when you strike an arc on top of this, it won't spit and spatter, because that's all the glass little thing there is all the impurities. When you're starting to do a TIG weld also, this is a suggestion to make it look more professional. Start in one spot and stop in that same spot. So we're going to weld the same direction all the way around this tube, all the way to the other side, going the same direction if we can. Obviously, not all the 100% of the time you're going to be able to do that, but it looks really nice if you can. So if at all costs, do that. So we're going to continue making our way around here. Get the lens back up there. You ready, Jake?
Yep.
You're going to start by overlapping that glass bead, come off. And this is step welding. I'm gonna wait, let it cool off, just like that. All right, we're gonna get all the way around this. You ready? Try to see if I can see this. All right, you ready?
Yep.
You're putting most of your heat down on what would be what I'm calling the non-cup tube, like the main tube there. Let it rest. Looks like we got a glass bead on there, so I'm gonna break that off. All right, you ready? Try to go for a long one here. Can you see the puddle, Jake?
Yeah.
Gonna finish this off here. Make sure you're overlapping that last, actually the first bead with the last one by a couple stitches. Burning it in there to make sure. And then swirl this out because you don't want one of those pinholes. So you let off the pedal lightly and swirl like this and just let go. And there shouldn't be a pinhole there now. I got a couple extra tubes here. We're gonna fit on there and weld. All right, aluminum welding. We want to change our welder to AC current. I have it set at 160 amps. That, like I said, might change depending on what I'm welding. I usually run in between 150 and 160. Your pre-flow, I have it set on 0.5, which could be less. And your post-flow is at 8. Some of the AC frequency that I use it, the balance at 75% and the frequency all the way up at 250. I think that's maxed out, and that's why the welder sounds so loud. That's just the settings I've always run and the settings I prefer. It gets the penetration and the cleanliness that I want. So that's how I set my welder up at 160 amps. The same argon settings, between 20 and 30. And that's, I think, about all that we need to cover on that for settings for aluminum welding on this Miller Dynasty 300. They're going to be different for, I mean, the numbers will be similar on other welders, but where they are at, the buttons and how you get there on different welders, it's all going to be different. So let's get started doing some aluminum welding. Okay. All right, we're going to start to do some aluminum real quick here, just old visuals. We're going to tack this probably every 2 inches. Probably put one here, and 2 in the middle. So let's do that real quick. This joint, this is 063 3003 aluminum. This is what we make our fuel tanks out of. This is a joint that I would see on a fuel tank. So I'm just going to demonstrate how I weld on this right here. So let's tack. Put that lens up on there. Actually, I'm just going to put one in the middle. All right. You ready, Jake? That's obviously a little different. Hopefully you can see what's going on with the puddles melting in that. My arm kept on sticking to the table, so I was trying to give you guys a good view of that, so it's not as good as I wanted, but oh well, you can still kind of see what's going on. So that's aluminum welding. Alright, so this is still hot, but I just wanted to also see, I'm going to show you penetration wise. Can you see that, Jake? It should be like a little worm on the inside of the weld. That's what you're looking for on a weld. It should be penetrated all the way through. Alright, final little clip here. This is my freehand challenge to anybody else who's out there TIG welding. The challenge is you need to hold the torch from the end like this. You can't rest your hand on the table. You need to hold your rod like this at the very end 4 inches and make a weld without stopping all the way down. I've bent up a piece of aluminum here. This is obviously not a legitimate way to weld, or it might be for some, I suppose, if you're that good. But I just wanted to try it out and challenge, if I can make it, to challenge those who are out there TIG welding if they wanted to try it themselves. So let's give it a shot. got hot. I think I did it. Got one little booger right there. So that's my challenge to anyone else wanting to try that. Let's do it. All right, so that's the video. I hope you enjoyed it. I hope you learned something. I hope you're able to try out that challenge. If you are able to complete it, please let me know. I'd like to see some videos on that and see if anybody else out there can do that. It's pretty challenging for me, so just some side notes. If you're wondering, as you've seen me in some of my videos, seeing all the race cars sitting behind me, this is where I work. The last 16 years I've been working here at McKinney Corp. I've done everything from building funny car chassis and dragster chassis, mounting funny car bodies. My main niche is making fuel tanks, making stuff like this right here, which is actually a dry sump tank for an alcohol funny car or a fuel funny car. This has been my day job, and I've really enjoyed it. So just kind of wanted to explain a little bit where I'm coming from. So if you're curious of what the heck is going on behind me, that's what is going on. So thanks for watching the video. I would appreciate it if you had subscribed if you enjoyed our video. Comment below if you've got any questions or if you were able to complete the TIG challenge, the freehand challenge. And hit the little bell and look forward to more videos coming down the road. Thanks again. I'm Matt Schwartz, and I am the Welding Geek.